Hello, I'm Jim Tressel, physics professor here at Massachusetts Community College. Just in time, I'm setting up a lab to just help students understand motion. This involves a thing called displacement, the actual position of the object, the velocity of objects, and the acceleration. To do this, we have what's called a linear air track, and this is used to show students linear motion, which is motion along a straight line. This device is very similar to an air hockey table, where in air hockey the air puck rides on a cushion of air. Here we have a car that rides on a cushion of air. And I can quickly just show you that by doing so we can eliminate almost all the friction. Now, to get this information off of the object, the motion of the object, we need to be able to figure out the position of the object as time goes on. To do that, we have what's called a spark source, which puts a high voltage pulse on this wire here, which wants to jump to ground, which is the track itself. That path is provided by a little wire that's attached from the car, and as you can see, when I push this button, a spark jumps from the wire down to the track. Now, at every point, as the car moves along the track, when the spark jumps to the track, it has to pass through a piece of paper which gets a little burn mark, which leaves a record of where the car is at that particular time. And so I can show you how this would work. I gotta careful I don't zap myself. So let the car go and leave a little trail of its position. Now, what I ask my students to do is to look at the tape, which will have points that are close together and farther apart as time goes on, because the time is the same, 1/10 of a second, but because the car is traveling faster as it goes down the incline, the space between these sparks get larger. So when they plot this graph, it looks something like this. And one thing about collecting data, by looking at points, you can see a general trend of the motion of the object, and you can predict where it was between the points and also perhaps beyond the points. Now, from this graph, I now ask the students to be able to learn techniques of how to determine the velocity of the object at every point, as well as the acceleration, which is how fast this line changes shape. So I have plenty of other experiments if you're interested, but you're welcome anytime.